Okay, hi everyone who's joining us. We are about to do a deep dive into trees. We are talking about the upcoming trees functionality for Wolfram language. So let's begin at the beginning. Should I open this guide page or should we look at the examples here of tree construction and so on?
So we had a look at these on our last meeting, and we wanted to here compare to the old design. So you complained that we had changed a few things and you wanted to understand better the changes we had implemented.
Okay.
So yes, we can have a look at this and then go to the comparison section if you want.
Well, okay, let's look at comparison.
Right. So there is this section difference with the original design. And so we have analyzed carefully all the details. Yep. And the main difference is that we have not yet implemented tree element, but it's planned to be implemented on top of the new framework based on the data structure. So most of the things here are about the details, which we didn't sort out completely the previous time on things like inheritance, options, etc.
Okay, fine. All right, let me bring up the trees. What is it called? Trees new? Yes.
Yep.
Go. It's really weird. Could somebody report that my open guide page mechanism is opening just a completely wacky directory?
Yeah, I can report it. Just to Roger.
Yeah.
Cool.
At least in the 12.3 prototype build, it might be different.
Okay. Yeah.
Okay. All right. So this gives us a sense of what's here. So let's remind ourselves. Okay. So tree element we believe in, data subtrees options, right?
Right.
Yep.
Okay. Okay.
And so there's a link to the ref page for tree element.
Okay. Okay, so now question, is there an outer wrapper of tree around the whole thing or not? Or is it just a tree element all the way down?
So our current idea is that the outer wrapper is actually tree element, and internally it's manipulating a data structure. So we will convert as needed for efficiency.
I'm sorry, I missed my question is, maybe we should just call tree element tree, since every subtree is a tree. Mm-hmm. Is there any difference between the big tree and the subtrees?
Not really. In input, we can construct nested trees as planned, and then internally this will get converted into a data structure. Mm-hmm. And if the user wants to output the input form or do pattern matching, the things we discussed recently, then it will be serialized to nested trees.
Right. I mean, it's really not obvious to me that we shouldn't just say, that we shouldn't just have tree.
Mm-hmm. I think the previous time we were just following the design of text element, XML element, things like that.
Right. No, I agree. But I think we didn't have the boldness to want to just call it tree. Right. Okay, hold on 1 second. I'm just going to make this SW notes 06. Okay, so the possibility is a pure tree whose subtrees are themselves trees. And so this would then be tree, data subtrees are not completely crazy. Okay, next question. When I get a tree, okay, it's a graph, right? It's treated as it's a purple outlined graph object. Is that correct?
Yes, currently it is.
Okay. Do we think it will eventually be a tree object distinct from a graph object?
No, so it is not giving a graph. That's not what we want for tree element.
Well, what do we want?
We want it to have head tree element, I thought.
No, I'm not asking that question, right? Look at this display, right? When I click it, it has a purple border. A purple border is the graph border, right? And so, for example, I can give graph options to this, presumably. Do you understand what I'm saying?
Yes, yes. I think we are doing this just temporarily because we don't have an alternative.
Okay. So one of the things we need to decide is, from a UI point of view, what does it look like? You know, presumably we have some kind of other border here. There's a tree border, okay? And presumably tree can take graph options, yes or no? I would think yes. Many of the graph options, maybe not all of them. Am I making sense?
Right. So options is one of the things we want to discuss today. And of course, we are planning a converter, a graph tree and tree graph.
I think that's good. I think that's good. Yeah. I mean, I think most of the time people will not be looking inside the tree object, probably.
Exactly.
Which possibly makes it, see, I think it'll be nice if you have a tree. Here's my tree, and I can now say, you know, re-option the thing like this, just like I do with graph all the time. Okay, and I would assume, do we need tree graph and graph tree, or do we just want it to be the case that graph of tree turns it into a graph and tree of graph turns it into a tree?
Potentially, there are things to control in the process because, for example, how do you choose the root node? And trees can have several nodes with the same payload, while graph cannot. So it's not.
I see. Well, I think those things should work, but I agree with you. We might want finer control.
Exactly. Yep.
Okay. All right.
So the problem of options and typesetting is important here because graph is a monolithic thing in which everything is controlled from the top level. But what happens when we nest lots of trees, each one having its own opinion of typesetting? This is, do you know what I mean?
I understand what you mean. I mean, I can see an argument to the big tree, the enveloping tree sort of imposes itself on everything. And I can see the argument that the subtrees can be their own thing. It's somehow, I'm thinking of patriarchal societies, so to speak, where the grandparent imposes themselves on all future generations. Never mind. I mean, you know, you get the point. The question is, do we want to work down like that, or do we want to allow the what am I saying? Do we want to allow the children to have their own opinion about things, so to speak? You know, Sandra on the live stream suggests a dark green border because trees are green. That's a cute idea. That is a cute idea, using green as a theming color for these things. Okay. So where should I look here? So this is tree element. We agree. I think it should probably be tree. Okay, since among other things, if I take a subtree of a tree, I still get a tree, right? So why? Yeah, I think it's the right thing. Now, an interesting question. See, with a graph, a node of a graph could be a graph. But in general, a node of a graph isn't a graph. Anyway, okay, that's my current opinion, is that a tree, it should just be tree. Okay, what are you saying here? Wrapper around the tree or tree data structure.
Yes, so we're explaining our current view of what tree element is.
Look, I think tree should have an opaque set of things inside it, but I think it should be as if, it should respond to part and this and that and the other the way that it should if it was not having some compiled opaque thing inside. Does that make sense?
So our plan would be to make tree atomic, and then we can do whatever we want with part.
Yeah, I think that's fine.
In a semantic way.
Yeah, I think that's fine.
Yeah, but
I have no problem with that. But I think, again, patterns, everything should be as if, right? Okay, so, the whole story is it's as if. By the way, is it obvious that this is the right way around? Data first, then subtrees? Yes, it's obvious, because then the leaf, right, data, if any, because it might be an empty, it might just be an intermediate node.
Yeah, the children might be optional, but the payload isn't.
No, the payload might be optional as well. The only payload, the parent only exists for their children. Right? You see what I'm saying? There's nothing like, this is a perfectly reasonable possibility where that's where there's none. There's no payload here.
Right.
Making sense?
Yes, we have discussed what's the meaning. So what should we put there to make it empty? I'm not sure it's empty list. Perhaps
nothing.
Perhaps null.
Perhaps nothing.
Nothing. I'm not sure about nothing, because nothing is kind of prepared for lists. I think null makes a better empty.
All right. Okay, fine. Although we have to think about, okay, fine. But that means a pure tree with no, null also has the feature that doesn't print, which is a good thing.
Exactly.
All right, then the leaf of the tree is, now why is that? I see. What happens if the subtree is not a tree object? Why doesn't that represent a leaf? Why can't I just say null, and then I could just say, hello, and then, this or whatever, right? Why isn't that? Go ahead.
I think that's fine. That
Okay.
could implicitly be like as if you had tree of hello, comma, tree of hello.
But it isn't tree of hello. It's tree. No, that's a different thing. Because if I say this represents a structure like this, right? If I put in, if that hello was a tree null hello, that's another level of tree.
Yes, but what Ian was saying is that having hello and tree hello would be formally equivalent, because everything is a node. Each node is a tree, potentially with children.
I don't understand what you're saying. This is a different structure. This one here and this one here.
So I'm not saying tree of null, comma, hello. I'm saying tree of hello, comma, none or empty list. Like it would be a tree who's
I see.
hello.
I see. So I'm sorry. Yeah, I got it the wrong way around. Yes. Okay. So this thing here. That seems like a really kind of a weird thing, right? In other words, this here, tree of hello, comma, null, I don't understand why we don't flip the argument order around and say tree of its subtrees, which it always has. And if it has something at that node, it's data. Because otherwise, you can just represent the tree that ends by putting these things in the subtree elements, right? Here.
Can you do expression tree? Type just some expression, f of, yeah, whatever. And second argument, do atoms, the string atoms. and then / tree visualization. This will happen automatically with the tree element. So nodes like that are what we're talking about, where they have nothing in them.
Yeah, and they're displayed wrong here.
Sure, yeah.
What's your point?
I'm saying I have what the notion that you're saying of just having a tree of a list of subtrees and not specifying the data. I'm saying it's useful because
right, fine. Well, then what I'm suggesting is that the way it works is it's tree of subtree, you know, subtree 1, subtree 2, et cetera, et cetera, et cetera. And that's the default form, right? And that if you want data, then at that node, you put node data there, okay? And if you want a tree that's ending, you just put the leaf information right here. Right? And unless that leaf is another tree, it's a leaf. Do you see what I'm saying?
Yeah.
Seems to me this makes more sense. Now, for pattern matching, again, I think it's going to make more sense because
so we may have trees whose content is a tree.
Whose node data is a tree.
Yes. And we use this to express the expressions whose head is not normal, right? So operator forms.
Yeah, well, let's look at that. I mean, let's look at that case because I don't think that's a there's nothing wrong with the node data being a tree here. Mm-hmm. The one thing that will be tricky is if the leaf is supposed to be a tree.
Exactly. So promoting data automatically to trees in the list of subtrees may be tricky in that sense. So that's why if the user is always explicit in saying, I want a tree here, then we can nest 2 trees and then we understand the content is.
I don't understand. I don't understand what you're saying. You're saying you want a tree in the trees section of the tree, mm-hmm. but you want it to not be part of the main tree. You want it to be a subtree, not a subtree, but a broken off tree, a different root system of the tree, so to speak.
Exactly. The whole yellow box contains a whole tree.
I understand. The yellow box contains a tree.
Yeah.
I think that's a very minority case, but I understand what you're saying.
Well, we find it every time that we do an operator forms tree form, we always get annoyed that it's not able to do the right thing. So that's why we want to do the right thing here. You see what I mean?
Yeah, I see what you mean, but I mean okay, so the question is a leaf, one possibility is that then the leaf okay, I've got another proposal. Maybe there is a wrapper tree leaf. That can be used here.
Well, so I view a leaf as a special case of a tree. Like there's tree leaf Q, which tests whether a tree is a leaf.
Okay, look. Either we have something where we say tree of nothing and then data, and every leaf looks like that. I think that's crazy because I think as we walk down a tree, we want to deliver raw data from its nodes. You see what I'm saying? So if I have a tree and I sample elements 1, 0, 1, 1, 0, I do not want to get a tree out. If that's the leaf, I want to just get an expression out. Am I making sense?
Yes, but so what we were planning here is always to be specific and say, give me the data. So for example, the tree for a leaf could have none in the first argument. And then we immediately see that this is a terminal thing.
Well, I mean, this is a more convenient version, right? Because this would elide correctly. Instead of having to have this null here, where the whole damn tree is full of nulls. Right?
Null is the data, not the list.
So these are about two different things, right?
Okay, like, I'm talking about, okay, here's the issue I'm addressing. I'm claiming that the argument order is wrong. I'm making two claims. Number one, the argument order is wrong. The subtrees should come first. Okay?
Mm-hmm.
And number two, the second issue is, when a tree is at the last level, can it have the payload directly in there? Or does it have, so here are possibilities, right? The payload is directly in the tree when it is ending, so to speak, right? So case one is it can go leaf, leaf, and then tree means it's more tree. You see what I'm saying? It's not a payload. Right? Mm-hmm. Okay. And then conceivably we could have something which says something like, I don't know exactly what it should be, for the rare case in which you want a tree as the actual leaf content, you put something like that there.
I think all you would need to do is put tree there instead of verbatim.
Tree of tree.
Yep.
I was thinking about tree of tree. Why is that right? Oh, I see what you're saying.
So the rule is, if it's a tree, trust me, I want a tree. Otherwise, implicitly wrap a tree around it. So if you
notice that structure is different from the usual structure, because that's not tree of a list tree. That's just tree of a pure tree, right? Of something which, because normally the first element here will be a list or an association if it's named ports. You see what I'm saying?
So you're saying normally under the assumption that we switch the order of arguments, right? So we have the children the first.
I'm saying children first, yes.
Mm-hmm. So that tree of tree would have to be like tree of like none, comma tree.
No. Well, okay, yes.
Well, so right now, tree of like tree element with one argument is just like you're saying for children.
Okay, so it's this. Yes, it's this.
And
which is not the worst thing in the world. What's that?
Yeah, and we could have tree of tree just be equivalent to that.
Yes. Yes, we could. Okay, question. I mean, what is a tree of no children? Is it the same as a leaf or not? I don't think it's the same as a leaf. I think that this is instead tree of none, comma tree.
An empty tree is not a leaf.
I'm sorry?
An empty tree is not a leaf. You're saying what is...
Right. Yeah. So this is not in fact a leaf. So the correct form of this would be...
No, I would say that is a leaf. That is a leaf whose data is a tree.
No, Danny is right. A tree with no children is not a leaf.
That's a definition of a leaf.
I bet it's not a good idea.
Where is that a definition of a leaf?
It's a leaf tree, right? So a leaf is a type of tree.
Wait a sec. You're talking two different but related things. An empty tree is not a leaf. A node with no children is a tree, is a leaf.
May I make a suggestion? I mean, for now, for safety, we can just say none as a first argument means this is representing a leaf.
Right.
Mm-hmm.
Because the first argument otherwise has to be a list or an association, right?
Right.
So, okay, so I'm going to argue that this is the right way around, because this way, for most of the content of a tree, like expression trees, well, it depends on how we're representing heads. The heads might be the node data or they might not, depending on how we're representing it.
Mm-hmm.
And then, so the tree is then, a tree is a list of subtrees. And if it is a purely abstract tree without any content at the nodes, then that's all it is, right?
Yep.
And it's just one argument. It's just one argument, tree of its subtrees. If, on the other hand, it is, so there are two forms of tagging, right? So tagging, one is tagging of nodes, And that is achieved by saying tree of subtrees, comma node tag, right? Or node payload, right? And the second case is tagging of edges. And that's achieved by saying tree of association, A goes to whatever it's going to.
Mm-hmm.
Subtree, blah, 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 blah. Make sense?
Yep.
Okay, good. Let's move on. Okay.
Needed at this point. I'm double booked for a function repository review.
I don't think you're strictly needed here, to my knowledge, but the other guys who actually set this up.
I think you can leave, Danny.
Okay, thanks. If there's a question, send me email or something, chat. Thanks a lot. Bye.
Thank you.
Okay, let's continue here. Okay, next.
Yeah.
Let me ask a question. How will the annotations framework work on trees?
That's exactly the next point.
Okay.
So,
okay.
If I remember correctly, the previous time we discussed this was more or less the same time at which the new annotation framework was being discussed. And so we were always waiting for that. But I don't know the answer. I don't know how to relate them.
Okay. So, I mean, I'm still not totally happy with the annotations framework. I find it a little bit hard to understand. Okay, so what's the issue here? The question is, if I want to color a tree node red, what do I do?
Right. And if you have a node red and the parent is blue, what's the color of the node?
Right. Right. Well, that's the question of inheritance down the tree. Right?
Mm-hmm. Which is new here. It doesn't exist in graph.
Indeed.
In a sense, dataset has a similar issue also of coloring all rows from here, all levels from here, things like that.
What do we do in dataset?
I think it's not decided yet either. At the moment, you can specify from outside things like all, 1. But you have to specify specifically the rows, the boxes.
Okay.
I mean, there's no way of saying inherit from all the previous levels, from something in the previous levels.
Well, we have the notion of inherited.
Yes, in cells. Yes, so cells probably is a good model for this.
You mean the formatting mechanism for cells?
Yes, in notebooks. Yeah.
How does that work? I mean, in that case, okay, we have option inheritance. So there we have the notion of a default. We can have default is, vertex colors, arrow inherited could be the default. Right? Or automatic could be the default. Automatic means I'm operating on my own, so to speak.
Mm-hmm.
Personally, I think automatic is a better default than inherited for most options, but maybe some options want to have inherited.
Mm-hmm. I see.
Now, I mean, what I would favor, okay, so let's talk about annotations. I am so confused by how annotations work in graphs. Remind me how annotations work in graphs.
I think the key point is that in graph, you refer to nodes by their content, while here we will refer to nodes by their position. And so we can still do annotate of tree, position goes to value. because we could have several nodes with the same payload. So we don't want to use it.
Okay, but I mean okay, so it's basically position goes to value, but what good does that do us? I see that the main point of that is you don't have to go in and reset something.
Right. We automatically will go to the correct place and put the value you want there. I mean, the value will have to be a rule itself of the option you want to modify.
Sure. But it seems to me that the following should work. If I say tree, oh boy. Okay, so look, if I've got a pure payload, I'll just say style of payload, red. Okay. On the other hand, if I want the tree element, I see. Then I have subtrees here, and then I would say vertex colors are a red, and whatever the default indication of a node is, the little circle or whatever, that will be the thing, right? And here I might say vertex size, arrow, whatever, vertex shape, vertex labels even, arrow, whatever. I could label that node independent of it being, I'm not sure how the labeling should work. Labeling is separate from the payload. You see what I'm saying?
Yes. So in principle, this would only affect that node, and only if the subtrees have inherited.
Exactly. In other words, there's no way of forcing yourself. I mean, this is the only way of forcing yourself on things is to use annotate with a pattern.
I see.
Right. So this should then work. Annotate tree, 110 triple blank arrow blah blah blah. See what I'm saying?
Right.
That seems like a perfectly reasonable way to do it. That's spraying stuff into that subtree. Now, okay, an interesting question. If you then modify that subtree, does it, how does that work? What does that actually do? Does that spray at that point specific options into the subtree, or does it spray inheriteds into the subtree?
Interesting. I don't know.
Well, I mean, actually, one way to do it would be just to do this. What you're spraying in there is vertex colors, arrow inherited. Right?
I see. So then we would use double blank and a separate red for the root node.
I suppose so. Yes. Yes, that's right.
Mm-hmm. I see.
This doesn't seem crazy. Okay. Mm-hmm. Let's move on. Nick is asking here whether he is correct about actually, there are 2 points Nick is making here. Okay, so first point he's making is it true that tree Q is match Q of tree well, I mean, these can be triple blanks and things like that. That doesn't need to be there. That's an optional thing.
I think so. There is a thing we were discussing before of having at the very bottom something in that list that doesn't have an explicit tree head.
Exactly, which is what we want to do. That's what we decided we're doing, because we're allowing, if you want a tree within a tree, mm-hmm. you're doing it with this mechanism, right?
Right. But I mean, I still think that in input, we would allow that. In output, we put the head so that things like this work. It feels more systematic.
Probably yes. Probably yes. But what does the leaf look like?
Tree none, data.
I'm skeptical. I think the other way is a better canonical form, but we can try it. We can try that.
You said, I thought you said you wanted the subtrees first and then the data.
Yes.
So then that would be tree of none, comma, data.
Yes, that's right.
Yeah.
I think that's what Jose just said, or not.
Yes, I did.
Okay. So Nick is pointing out that more consistent with graph would be annotate the list tree comma position. And then, oh yeah, this is right actually. Tree comma position and then the vertex colors, arrow, whatever. Right, that's the better thing to do.
Mm-hmm. Yeah.
Yeah,
that's correct.
Okay. Okay. All right, onward. Use of association.
Right. So this is something also that is slightly different from the old design. So in the old design, the payload itself was always an association in which a key was what we called name at that point, which is now payload or data. But I think this is potentially confusing with,
I think
just having.
I don't see a reason to do that.
Yeah. It's better to have everything in options now. And then children association, yes.
Yeah, which that's fine. They can be an association. I don't see a problem with this.
There is a technical implementation thing, but we will figure out. Now, before we move on, there is something that we were a bit worried about. In the same way that in both in graphing and in trees, the data can have a different label, we were wondering whether the edges could also have different labels. For example, if we put associations as base for the edges, we cannot have two edges with the same label. Would that be needed?
I understand the issue. Well, one thing is what it is, and the other thing is what it's labeled.
Right, exactly. And in trees, we can fully separate it.
Yeah, the only issue is that these are tree elements designators. Yeah, the difficulty is we get to say anything we want about the nodes. We get to annotate the nodes, but we don't get to annotate the edges. The only way we get to annotate the edges is in the association.
But in a sense, each edge points to a node. So we could store in the node the information about its edge.
Oh, I see what you're saying. Yeah, that makes perfect sense. Yes, that makes perfect sense. But what if there are, wait a minute, if there are two edges pointing to the same node?
That cannot happen in our trees.
Hold on, let me think about this for a second. Am I totally confused? Is that obvious? Oh yeah, because you're right, because it's a literal unrolled tree. It's not like a graph.
Exactly, yes.
I've spent too much time looking at multi-way systems where that can happen.
Right.
Which are not trees, turns out.
The concept of tree is more general. So technically we are using something called oriented, ordered, rooted tree. So it's not the fully general tree concept.
Well, I think the more general tree concept is a graph, basically.
Yes, sure, but yeah.
Okay.
So
okay.
This is an example in which we may want to refer with party specs using Monday, but the label actually want to show it MO.
Something else. Yeah, that's fine. Seems fine to me. Okay. We already talked about this tree extract.
Yes. So this is also another thing that we changed slightly. So in the past, in the previous design, there were two arguments to refer to the path through the tree and then the path inside the data.
Yeah.
Well, now, because we can have nested trees, as we discussed before for operator forms, we want to have a single path specification. And so we use the keyword data to separate the moment in which you jump from the tree to its data and then continue.
Bluff. Okay, let me understand this, okay? So what you're saying is if I if I get down to a particular leaf.
No.
Wait a minute. You're saying jumping to the payload of a node.
Exactly. And then continue borrowing there.
Right. And that's something we don't have. Okay, so far we have two ways of accessing different sort of types of parts of expressions. Well, actually, we have three ways. So currently we have positive indices, 2, 3, 5, et cetera, et cetera, et cetera. We have the somewhat weird 0 for the head, and we have key for going into an association.
Mm-hmm.
For referencing a piece of an association. So what you're proposing is another thing which jumps to the data piece of a tree.
Right. This is very specific for trees. But it allows a single continuous thing.
Well, let's be realistic. I mean, the thing of annotating an expression, we may very well want at some point in the future expressions to be annotated by, like, the abstract syntax tree for, in the package system, for example. In the new package system will probably be one of these trees. And so this will be a general annotator for a node of an expression. Right? I'm not thrilled about the fact that isn't a symbol.
That's an idea. Yeah, we could use a symbol because it's something so specific and important.
Well, but also, my question is the correct way to do this to have, parts 2, 3, 4, and then have something which says, inside or something? It's not the right term. Blah, 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 blah. Whatever it is, payload key, payload something. In other words, rather than just continuing in that sublist, in that list, right, to indicate you're going into something else, which then has its own. I don't know if this is a good idea. I don't know if it's a good idea.
So I think that what it's doing with data is analogous to what it's doing with 2, 1, and 3.
Sure, but it is accessing another pocket, just like key is accessing another pocket, right? The 2, 1, 3 thing is just saying, walk down, walk down the parts here, right? But what you're saying is we've already got this notion of another pocket, right? A different kind of pocket in this case is the pockets that are indexed by A and B, right? And we've also got the pocket that says index the 0 element there. I mean, that was a very primitive, different kind of pocket.
In a sense, 2, 3, and 4 are like specifications in the list of children. So
yes.
So
and 0 is more like the specification of the head.
Right.
But we don't want to use 0, I think. We don't want to use a raw 0. 0 will be the closest to the thing that we have here on the particular tree element. Except I don't like using 0.
Also, with expressions, the 0 is it's 0 indexed of the sub-expressions at level 1, whereas if we'd used 0 for data, then it's kind of it's not counting the children like 1, 2, and 3 are. Trees are doing something.
Wait a second. Nor is this. What we're talking about is jumping to the payload of a node, right, rather than its children. Right. So the question is, and normally the payload of a node, if I say f of x, y, z, or f of x, y, in some sense, f is the payload of that node. Right? I mean, if I say expression graph of this, right? Oh, what the heck? What do I want to do here? Expression tree. Do I have that?
Yep.
Yes.
And then tree visualization.
Okay, rather unbeautiful. But this is exactly that. This is working exactly that way. F is the payload of that node. You see what I'm saying?
Mm-hmm.
Yes. But
so what I'm saying is do level of f of x, y, comma, list 1.
Sure.
Heads goes to true.
What?
Do heads goes to true.
Yeah. So I'm making the argument.
So 0 is like indexing this list starting at 0. Whereas trees doesn't have something like that. It's not like you start data and yeah.
So what? That's just the print form of this. I mean, that's why we called it element 0.
Mm-hmm. Yes, but this is important. That's why expression tree has a second argument to specify what you want. So what's the other string, Ian?
Okay, so I'm making the argument that it should be 0. Look, I'm making the argument that this should be 0. That instead of data, it should just be 0.
Mm-hmm. So part 0 of a tree is its data. That's what you're saying.
That's what I'm thinking. I don't know whether it's part 0, and I don't know how this relates to part extraction. You see what I'm saying? I mean, this isn't part extraction. This is a tree extract, which is a different function from from just standard part extraction. Although standard part extraction should work.
Right. So that's why we want something that can be as close as possible to part specs and position specs.
I understand, which is why you're trying to avoid 0, although right. 0 seems like it is the closest thing.
It seems very close, yes, indeed. But it would be nice if 0 could be maintained to represent heads.
I agree. Okay, so what is this thing? Is there any name that we have, the nuns or anything like that, or automatics?
I mean, your idea of symbol tree something, tree data, tree. Like, I like that.
Yeah, but well, I mean, what about inherited? Isn't quite right. What are some other things like that that are already existing names? Mm-hmm. Full is another one. That isn't quite right either. All right, so we need a name for that. I don't know what it is. It's close to being 0, but it isn't 0. I mean, another name which we don't use anywhere else is content. None of these I like very much. It should be something very generic.
So, because tree extract will extract trees, we were planning on having a tree data function that extracts the data. So perhaps we can put there tree data. Because this will just be a symbol. It somehow represents the function acting, a bit like dataset does.
Maybe. I'm not convinced. Let's keep going. Nick is commenting, nice to have the ability to get position referencing both structure and data, e.g. to get the position of node AAA anywhere in such and such a tree. Okay, wait a minute. Let's see, this is what Nick is talking about. A tree. I don't get this.
Is this supposed to be tree cases? And you're looking for subtrees and doing a pattern replacement?
Yeah, well, tree. I think this is tree cases, not tree position.
Yeah.
I'm not quite sure I understand this because this looks like it's spanning two trees. Oh, I see. This is a sibling tree. This is matching this tree, but it has as a sibling this tree here. I think this is the brackets are the wrong way around here. Yeah, there we go.
So that matches a tree with no payload with two children and replaces it with the first child.
Yeah, that looks okay. I think we'll be able to do that. Okay, let's keep going here. Do I need to look at these?
This is a collection of minor other things, if you're interested. And then this is in the section about changes, we have added now many things. So.
Okay, he wants the position of a subtree for a match. Oh, I see. The issue is, and you're saying also for position, that instead of saying in position of expr, some random, you want to know in this, let's say we've got x blank, y blank of 0 or something here. You want to know the position of the 0 in here when the outer matching is of this form. Do you see what I'm saying?
I think so, but position cannot do that right now.
No, I know. I mean, this case would be more extreme.
Yep.
That's an interesting idea. We should add that to an ILG agenda and talk about that in the context of position.
Right. This has appeared other times, the fact that cases takes these rules in the second argument, but position cannot.
What the heck would position do with rules?
We don't know, but perhaps it can be used in this way.
Right. I think that's what Nick is suggesting.
Exactly.
Right.
Yeah. So that's why I mentioned it.
Let's bring that up as an ILD agenda item. Okay.
Yep.
Okay, let's move on here. All right.
Right. So yeah, so this is all about visualization. These are the last things we got from design.
2018 prototype. Blah. Well, it's nicer than this, but I mean, I could lose the brown. I think we unbrowned our graphs, but I like the rounded corners here. I like the lighter color of the borders. And in terms of these, a default node, I think this isn't a bad idea. And then this is a default leaf.
Empty leaf, yeah.
Right. Seems reasonable to me. I mean, I think this needs a bit of modernization, but otherwise seems good.
So what about the idea of distinguishing the leaves with some different corners from the other internal nodes?
Possibly.
I'm not sure it's useful, but I think it's something we have discussed.
Yeah, possibly. I think it's we need people from design here to discuss this in detail. But this looks like a good, reasonable direction to go in. What I would do is I would slightly darken the border of the leaf. Okay, to begin with.
I see.
Something quite subtle. Because it depends on the meaning of the thing. You know, sometimes you won't want it. It's just like, you know, the ultra hack that we've been, you know, that's a 1/3 of a century hack is, you know, is this hack where you don't show the double quotes, right? You really don't show them.
Mm-hmm.
And that hack has been very useful. And I think, you know, in some of these things, it's like, well, look, if you want borders here, then put borders on here. Make sense?
Yep.
You know, I can imagine at the top level of a tree wanting to say something like, something like this. To just say, I want to do this for all my, I mean, how would I otherwise do that? If I want to just do that for all leaves in the tree, you know what? I think we want this. We want leaf style, and we want something like node style. Because that way, and that says, that's exactly doing this thing about, that's saying down the tree, I want this to work all the way down. It can be overridden by a specific thing, but if you say leaf style arrow red or something, then it just makes all the leaves red.
Mm-hmm.
I think we want something like this. Okay. Should we go on here?
What about something like inherited style, which is able to, you know.
Oh, but I think it's convenient to just say, okay, I've got this tree. Everything in this subtree, I want the leaves to be this way. Everything in the subtree, I want the nodes to be this way.
I understand the idea. What I'm worried about is the tailoring towards leaves and nodes only. What about if I want something in a branch?
Yeah, I understand. On the edges.
Right, exactly. So,
well, that's easy enough because you just told me how to do that. Because the node style, right, that's just telling me, I mean, okay, I admit that the leaves it doesn't handle, but that's in fact your scheme that has an edge style, does that handle? Oh yeah, right. The node style is a downward. The edge style of a given node. Wait a minute. It's the incoming edge for a tree, right?
Yeah.
That is the edge style.
Mm-hmm.
Okay, so in this case, how would you label, how would you color, you know, how would you make a dotted line for the incoming edge of a leaf?
The same thing we just said.
But how would you do it? Because
edge style goes to something.
Of what? Edge style of what? Because remember the leaf.
Ash.
Yep.
I don't know what it is.
What's that? No. Look. The leaf is just a raw leaf here. Right, so how do you wrap an edge style on that leaf?
So in a sense,
it doesn't look like a leaf. That looks like a tree with multiple children.
No. That's a leaf. That's what we agreed. That unless you wrap another tree there, any expression other than a tree is a literal leaf.
Mm-hmm.
Right? So what I'm asking is, if you want an edge style coming into that leaf, how do you do it?
Tree of leaf, comma, edge style.
All right, fine. But then there's an argument. Okay. I'm not sure then about this, but I mean, this particular thing, this idea, yeah, your idea that every node, it may be convenient to have a way of referencing the leaves separately. So this, you're saying, really should be tree of something like that, which would give the inherited style for everything. Maybe. Actually, we could even call it tree style, because it is the style of the whole tree. As opposed to just that node. Right?
See.
I think this is not completely stupid. Okay, so let's keep going here. Okay. Okay, I don't understand yet the heads goes to true stuff here. Okay.
Yeah, so
sure, that note was just more about your instruction that tree form should be consistent with this visualization.
Yes, well, that's for sure.
Yep.
Tree structure. Yes, we need that. Something like tree structure form. I don't know if that's the right term. Okay. What are we looking at here? Is this old? I don't understand what this is all about.
No, this is our new notes of design. We are not looking at comparison anymore.
Okay, fine.
So what we are wondering here is the various ways of visualizing a tree that we will need.
Okay. Yeah. I don't know whether this is the right name for this underlined form. And what would that do? It would use the node labels as the labels of the underlines. Is that correct?
I think that's correct, yeah.
Okay. Okay. Well, yes, I think this tree outline, I mean, I personally prefer tree browse if it's an interactive thing. I think. Possibly tree outline, but I think tree browse is better because I think tree outline, it's not clear it's a verb. Makes sense?
Okay.
Tree highlight.
This tries
I
to follow.
don't know. I think not, because I think it's just annotate of a particular, the reason we need graph highlight is because it's highlighting. Well, it might be useful because it's like a bank specified annotation, so to speak. It's like if we say tree highlight and then we list 3 things to highlight, it'll automatically pick 3 different colors, et cetera, et cetera, et cetera.
Right. For large objects, this could be quite useful.
Right. Okay. Well, anyway, I think that's that's more in the luxury items department. We got plenty of stuff to do before that. That's effectively an annotate with appropriate options.
Right. Indeed.
Okay. What's the issue here? So if I say dendrogram of range of 10, it's a very uninteresting dendrogram. I mean, let's do dendrogram of random real 1010. Okay, there we go. So what's the question here?
So this is a tree that doesn't have data at the payloads. It only has it at the leaves. So
yeah, well, great.
If you had a tree that did have data in its payloads, would you still want to have a dendrogram plot or something like that.
Yes.
And yeah.
It's just one of the styles of tree visualization. I don't know whether this is, look, the fact that these things are drawn squared off like this, I don't think is particularly dendrogram specific. I don't think. I think that's just a style of tree visualization.
I see.
I don't know what the significance of the height of this thing is. I think that's giving us an indication of the some kind of closeness measure or something. I don't really know what that is. But a squared off tree like this, absolutely. We absolutely need this. I mean, this is just one of the styles. Like, yeah, I mean, we should have had this in graph visualization. Tree plot should have this. Right?
Okay.
Tree plot should work with trees. I mean, as it works with graphs. Okay, tree element patterns. Okay, what on earth is this now? Oh boy, sparse array as a first argument to tree is an interesting one, which surely should be supported. It's not very difficult to support. Well,
but the point here is that we were planning to have tree element with patterns inside, or rules tree because patterns inside, and construct a tree whose payloads are patterns, while sparse array will understand as a construction mechanism rather than constructing a sparse array whose content are patterns.
yeah, what is the objective here altogether?
Well, in this section, we explained that we need to be able to do pattern matching with trees. I think we agree. The main question would be whether we need a tree pattern or not, or we can live with tree itself.
Okay, so what are we patternizing in the tree?
The whole tree, the whole subtree.
Okay, well, that's fine. That's just part of the first argument, because the first argument is a tree, is a list of subtrees, and they can be patternized. What's the issue?
So imagine that you want to construct one of those trees with patterns using rules tree.
Okay.
And then rules tree with patterns, which is in the second line, I think should return a tree element or tree containing patterns.
Tree element containing patterns. Yeah, it could, but I mean, there's a different issue, which is, okay, here's the thing I might want to do. I've got a tree, and I want everything whose tree. Yeah, here's an extreme case, right? I want something like this. All elements whose tree designation is that. This is a replace part type operation. Something like that. Or give me all elements whose, I mean, presumably tree cases. No, how would I do that? This is a form of tree extract. If I want all tree pieces, all subtrees whose paths to get to them are like that.
Yes.
So I think that's just tree extract, if I'm not mistaken.
But tree extract doesn't take patterns.
Maybe well, maybe it should. I mean, okay, this is clearly useful because to get this as a ordinary pattern, I've got to go and have this rodentified pattern of tree of tree of tree of tree of tree, right? Which is a big nuisance. See what I'm saying?
Yes. This question is not related to trees. It's also in general, whether extract should take patterns and.
What does extract? Extract returns directly the expression, not a list of expressions, right? So I don't think it could really, maybe there's an extract list.
No, it does extract the list of expressions. If you have a list of position specs, it will return a list of expressions.
I know, but this isn't a list of position specs. This is a pattern, which is like if you give it, look, if I say, it's just going to give me a literal piece.
Right, but if you put a list of list 1, 2, it will give you.
Sure, absolutely, but it seems wrong that this will suddenly give me a list out.
I think I know how to do it. So take your expression in the first argument, the extract of the first argument in extract, and do position of that comma blank. So now that's all the list of all positions. Now we have to pattern match these and extract the cases that match your pattern.
Exactly. Yeah, no, I agree with the semantics.
Right.
I'm objecting to the fact that I think extract is the wrong thing to do that. Because I'm concerned about the fact that extract, well, maybe it's okay. I mean, that if it's given a pattern, it will always return a list. If it's given a non-pattern, it will typically try to return a single element.
Oh, I see what you mean.
Right, which is why I'm proposing more something like extract list, which will be the analog of replace list, that will say extract in all possible ways. So for example, if I said here, well, if I just said blank here, right, if I say extract blah blank, right, then it should give me, well, I don't know what blank should do, but I think more, if I say blank, blank, blank like that, then it should give me the complete list of all parts. Right, then that will be equivalent of level this thing, comma, 0, comma, infinity. I think that's sort of a useful function, and for trees, it's going to be more useful. Honestly, that function would also be useful for things like data sets. Because that would give me, like, if I want, well, really, does it? What's the difference between extract list and comma all? Actually, I'm about to blow up my own argument. Because look at this. Oh.
All only works in the first argument. Write all comma 1.
Why doesn't it work in the second argument?
It's a limitation in extract.
But is that... But okay, but that's blowing up my argument that it always returns a single element when it's a form like that. What do you mean it's a limitation of extract? Is it's just a bug, or is it
No, when all was added to extract, it was added this way. You can have any number of alls at the beginning, but always at the beginning.
But it doesn't need to be that way. There's nothing semantically blocking it from doing the other case, right?
Well, ragged cases might get tricky.
Okay, separate discussion.
Yep.
Okay, let's continue here.
I think just one more thing. This links with something we have discussed other times, which is symbolic position specs, something that represents like a diagonal or.
Yes.
So it's something that a single thing returns a list or represents a list of.
Fair enough. And as you say, we've already crossed that bridge by having the all case. Hold on just 1 second here. Second. Okay. Back. All right, let's keep going. All right, so there's still some questions here. Okay, empty trees.
I think we discussed this.
I don't think we care about this. I think we figured out what we need to figure out with this.
Yeah.
Non-terminal nodes, I think we've also discussed this, haven't we?
Yes.
Okay.
I mean, there's things here that we haven't discussed in this meeting, like the fact that depth and how negative level specs work with that.
Ah. Okay. Well, tree depth.
Mm-hmm. Tree depth.
Yeah, tree depth seems straightforward to me. What's complicated about tree depth?
So tree depth of an internal or a non-terminal leaf would be like +1 compared to a terminal leaf. It's as if it had another level.
Well, the tree depth is not the depth. Is that what you're saying?
No, this is the difference between like F and F bracket bracket.
Okay, in this tree here, what is its depth?
Its tree depth is 1.
Are these terminal nodes? Those are terminal nodes, right? I don't know, maybe that's not a terminal node, but let's assume these are all terminal nodes here.
Yeah.
Its tree depth is 1, I see, but its depth.
But so then if you changed one of the leaves to a non-terminal leaf, then the depth would increase by 1, even though you didn't actually add another level to the tree.
What the heck is a non-terminal leaf? I mean, so look, in our way of setting this up, where we say tree of leaf, comma, whatever, right? Mm-hmm. Tree of A, comma, B, okay? No payload there, all right? Mm-hmm. What is the depth of that tree? The tree depth of that is 1, I would assume, or is it 0? I think it's 1. It's got to be 1.
I would say that would be 1.
Okay. All right, great. Okay, so now if one of these is a tree, even if it has...
So now say none, comma, A.
Okay. Okay, so what's the tree depth?
Say empty list, comma, A.
Yeah, what's the tree depth of that? I think it's probably 2.
That would be 2.
I'm fine with that.
Right, even though... right, tree of empty list, comma, A would be a non-terminal leaf.
Okay, let me make a comment about this. Let me make a comment. I think this should be indicated visually in some way. This is a vestigial tree. This isn't the same as just B here.
Right, so you designed terminal and non-terminal leaves already. So non-terminal leaves would render exactly the same as like a regular subtree in the middle of the tree.
Okay,
terminal
fine.
leaves would be the things that...
Great, then I don't see any problem with this tree depth interpretation.
Okay, and so you're also okay with level -1 would be just the terminal leaves, and then non-terminal leaves would be level -2.
Yeah, level -1 is the terminal leaves. Yes, is it? So level -1 of this tree.
So in particular, like tree depth and tree level don't need like a leaf type option. It's fine for them to, you know.
Okay, so I claim that this should be AB.
Yep.
I think that's fine.
If you did tree level of -1 of the tree right above, then you would only get B.
That's correct.
Okay, perfect.
Seems right to me. Okay. Nick is commenting on various things about position pattern. I think these seem like great Nick function repository suggestions. Well, okay, so this is a wrapper. Oh, that's interesting. What is this? That's basically a thing to put into a part extractor that represents a patterned part. Yeah. Well, and there's an example here of position cases. Yeah, right. It's this kind of thing. I agree that these things could perfectly well work. Okay, anyway, let's move on because it's not the subject here. Tree depth we just talked about.
Yep.
Array depth versus array. Is that a subcase of this? What the heck what does array depth have to do?
So this is what we discussed. Tree depth of tree list AB, is that 1 or is that
okay, fine. So we just handled this.
Yep, exactly.
Okay, tree graph.
You haven't seen. So you specify a pattern in the second argument, and then it gives you the level that it finds that pattern.
Okay. I wonder why depth doesn't do that. Because it's a version 1 function that hasn't been touched. Oh my God, look at that. Look at all those updates. Why is there a bullet thing there and a vertical bar here? Can we find that out? Oh, because these are all updates. Yeah, okay. Okay, well, I didn't know it had so much care exercised on it. Fair enough.
Perhaps to update it for new structures.
Oh, that's most likely right. Yeah. Okay. All right, what's next? Tree graph. Now I use the data as the vertices rather than unique integers. I see. So it uses the data from the vertices in the graph as the payload in the tree.
So this is going from tree and producing a graph.
Oh. So what is it doing? Using data as vertices rather than unique integers. Can I see this work?
Yeah, so open ref tree graph extension. And these examples should work.
The problem here is that if you have several nodes with the same payload, the graph is not going to reproduce the tree.
And there's an example of that lower.
So hold on a second. This is, right now I have to say tree visualization of this.
Yes.
By the way, I mean, this default size is all wrong. You do know that, right?
Yeah, I'm pretty sure everything about this is wrong.
Okay, but in general, because these things have textual data here, you should be, that thing should be scrunched up about that size, right? And if you need to, in other words, I think that the average distance between these sort of lines of tree, if you understand what I'm saying, should be on the order of twice the height of the nodes, maybe. See what I'm saying?
Yep.
Okay, so now what's the question here? So this is tree visualization. So now if I say tree graph of this.
Sorry, you complicated. There's a private symbol that you have to copy off of the ref page for now.
For which? Tree graph?
Yep.
That wasn't very helpful. Oh, because I wrapped in tree visualization. Okay, so this is the graph, and if I save that graph, vertex labels to automatic, Dandosaurus. But now, if I were to go back here, if I were to go here, and I were to say, I can guess what's going to happen here, and I would say D goes to A, I'm going to have a weird graph.
Right.
Humph. Okay. Well, we got a problem there.
So what we were planning is to have a function that intercepts the payloads with the position and create something new. You can say still keep only the data, or merge it with the position in some way.
Yeah. I mean, a little bit like index for nearest and things like this.
Exactly.
I think this is going to cause horrendous bugs. This lack of
well, it's a matter of deciding the default. We could say that by default we place pairs, payload, comma, position.
No, I understand that. I understand that. But I'm asking the question, if you want it to round trip, is there a way to do that by having the graph distinguish its nodes in some way that is removable when you go back to the tree?
I see.
I mean, we could have a convention that graph tree strips out certain kinds of things associated with it. For example, let's say that it was of the form index arrow payload. Okay, we could remove the, index part of that when we go to the tree, or just use it to actually make the indices in the tree. In other words, and then if a graph doesn't have its node names being rules like that, then we just right ahead and make a tree if we can. We might not be able to make a tree. Do you see what I'm saying?
You should always be able to make. So the other direction, I think, has no problems. Like graph tree, you already have a graph where the vertices are all distinct by virtue of it being tree graph queue.
No, you mean tree graph. Making a graph.
Making
out of a tree.
Graph fine. It's making.
No, how can you make a tree from a graph? No, nonsense. What if my graph is just a cycle? I can't make a tree.
Right, it has to be tree graph queue. That's what I'm saying.
Okay, fine.
You have a tree graph queue graph. You do graph tree, and you get a tree, and then you do tree graph. You'll get back the original graph.
Well, you will right now, yes.
With the same vertices, yeah.
Right, exactly. What I'm saying is, if you go from a tree to a graph, to put in annotations at the nodes of the graph that have the form tree indices goes to payload, okay? That's the default. And that then on the way back, we say by default, any graph whose node names are blah, arrow, blah, gets stripped. Now we have to parameterize this because it might go wrong. But I think that's probably the basic idea, so that we can round trip. Make sense?
Yes.
I have this bad feeling we might regret this, but I think it's okay. Ettore on the live stream is asking about, can this be used to visualize decision trees from classify? We certainly hope so. It is one of the intended use cases. Have you talked to the machine learning people about that, Ian?
No. I brought this up with Jesse.
Okay.
But I need to connect Ian and Jesse.
Okay, please do. Because Jesse didn't know that this project was happening with trees, and he's in the process of making trees. Right. It should give a directed graph by default. If you don't want a directed graph, say undirected graph of the thing, in my view. Do you agree?
Yes.
Okay.
I agree.
Okay. Tree extra boy. Okay.
So we discussed last week that we wanted to eliminate the symbol and keep lists.
Yeah, I think that's correct.
I mean, it's going to lead to some small ambiguities if we just have to analyze how problematic they are.
Okay. But now genealogical position specs.
I think this is something that will be very useful with trees, being able to refer to all grandchildren and things like that.
Yeah, I agree. One issue with grandchildren is a grandchild is like a double blank, not a grand, no, that's a grand star child, so to speak. Grand to the end child. But what I mean is a grandparent represents two elements in the tree path. But so what's the idea here? The idea is that we would have strings. What the heck's going to happen if we're referencing associations inside here?
Right. So associations would require key.
That's annoying.
Or at least.
Okay, I have a different suggestion. I have a different suggestion. It's a pun. Tree relative. That's the wrapper for each of these things. So in other words, if you want, you're going down 1, 2, 3, cousin, first cousin, whatever, tree relative, cousin. You see what I'm saying? So it's going in this direction of symbolic parts.
I see.
I'm concerned about the following case, okay? Tree relative parent, right? That is that element there, isn't it?
Yes.
Yes, it's undoing the last one, yeah.
Right, which is fine.
But you may have had children and then comma parent, and then that would be the parent. I mean, you know what I mean? Cousins, you could have something other than just an index there.
I like the term tree relative. I think that's a very amusing pun. So I'm saying it's both relative to the tree and it's a relative in the same sense that, you know what I'm talking about.
Yeah.
I can imagine tree relative actually being a thing that we use in general part specifications. Let me look at what some of these are here. Oh my God, some of these are horrendous.
And something important here is that some of them are plurals. And so they are like all, they will return a list of parts.
Wait a minute, how can you be, wait a minute, what if I say aunts instead of uncles? Okay, okay, hold on. Human genealogical trees are not trees. Is that a true statement?
Yes, in full generality, they're a DAG. A DAG where every vertex has...
It's a begats so-and-so.
Yep.
Right?
Mm-hmm.
Okay, so hold on. Okay, but in genealogy, right, there's this notion of an hourglass diagram, right? Where there's you in the middle, then your children are below, and then your parents are above, right?
Mm-hmm.
And then you have two parents. I'm so confused.
So these are rooted trees. So we would not have the hourglass. We would just have like the lower half of the hourglass.
Right, but what if I want my ancestors? What if I want a tree of my ancestors?
But it's a reverted tree. So I think that part is easy. You just use 2 trees, one for the past, one for the future. So, but
but that's not right, because if you know, you're, you know, like, you know, if you marry your first cousin and you have, you know, in like the Darwin
you would need
style.
a graph in general to represent family relationships. You would need a directed acyclic graph where every vertex has 2 parent nodes. And you get a tree from that by arbitrarily selecting 1 parent node for each vertex that you're interested in. And there you obtain a tree. And because of, you know, the fact that every 2 humans is technically some form of cousin to every other human, that will not be unique. It'll depend on the choice of which parent you choose to represent the family tree as a tree.
I see. Well, and you know, we're no doubt cousins in 18 different ways, so to speak.
Exactly.
Okay, so is there a generic, okay, wait a minute. For an uncle, right? What is an uncle in this tree? So if I'm here, right, this is my parent, and this here is the sibling of my parent, right?
Yep.
So that's the uncle of this node.
Yep.
Is that correct?
B is the data at the uncle of E. Yep.
Okay. It's a pity there isn't a gender-neutral aunt-uncle term, is there?
There is for nieces and nephews.
What is it?
Nibblings.
Oh, that's ridiculous. I've never heard that. Is that new, or has that been
Jose,
around?
where did you find that?
We were worried about that, and we were looking for the existing ones. And apparently, nibblings is something that is getting accepted. It's relatively new, but the other cases there is no agreement at all.
I see. Nibblings as in like siblings.
Yes.
Yeah, because I mean, cousin obviously isn't in English, at least, is not gender specific. I don't know. Maybe it is in other languages. I don't know. What is an ascendant? Is that ancestors or descendants?
It's the inverse of descendants.
Then we should call it ancestors, because that's what everybody calls it.
Okay.
Like the ancestor of a node. The ascendant is like a, you know, some kind of, who knows what. Well, I never heard of a nibbling. That's kind of a cool word. Is it a new word, or has it been around for 100 years?
I think it's relatively new. Let me try to find that again.
Okay. But so you're, okay, what about a great uncle, for example? Or now, if we have tree relative, we could imagine having because, okay, look, it gets, you know, in Wolfram Alpha, okay, let's do the following thing. In Wolfram Alpha, we do have the concept of a, you know, first cousin 3 times removed, that kind of thing, right? The concept of cousins removed is a thing in trees, isn't it? That's not something specific to genealogical trees.
It's about the relative difference in level compared to your least common ancestor.
I see. The cousin, the second cousin, is the common ancestor as a grandparent.
And then the removal is how, you know, what's the difference at the levels of the two.
Okay, so fine. So what we're going to need, and this is a separate thing, and it will be packed inside tree relative, will be a way of doing control equals third cousin once removed, and turning that into some symbolic representation of the genealogical representation of the genealogical thing. Now there is a standard thing, I think, used in genealogy programs that represents those. You know, it's a standard, rather rather packed numerical vector form of these kinds of relations, right? I mean, it's basically saying, how many do you go back? I think it's what you're saying. How far? Okay. So, by the way, bizarrely, the same thing has come up in our physics project. This is in branchial graphs. This is, how many, it's a common ancestry graph.
Mm-hmm. I wrote some definitions out in bullet points in the agenda.
Where?
Under genealogical position specs.
Not seeing it.
Up, right there.
Oh, here, yes. Children is fine. Subtrees and descendants are fine. Parent is fine. Boy.
So nobody talks about negative first and zeroth cousins because those are immediate family and they have different words. Like
I know, but we there's no reason why we can't do that.
And then the other thing is like niece and nephew.
What is the minus second cousin?
Minor second cousin?
Minus tooth cousin.
I don't think there is one.
That doesn't exist because that's a forward relation.
Your negative first cousin 0 times removed is yourself.
Right. Okay, right. Your first cousin, your 0th cousin is your siblings. Is that correct?
Siblings and then nieces, nephews, aunts, uncles, grandnieces, etc.
No, wait. Your 0th cousin.
0th cousin 0 times removed is cousins. Or siblings.
No.
Siblings.
Siblings.
Yes.
0th cousin.
0th cousin 0 times removed is siblings. Sorry.
Right, but the default number of times removed is, by default, an nth cousin is n times the default, right? A first cousin. Removed. No, but it's 0 times removed, as in it's at the same level of the genealogical tree.
Exactly.
Right. Okay, and this is just saying what the common ancestry is. So this is the I don't know. I think we're calling it branchial depth in the physics project. Boy.
And the other point is that like words like niece and nephew, those specify who is older or who is at the higher level. But in general, like second cousin 3 times removed does not specify which one is closer to the common ancestor. But you could
I'm sorry. Say that again.
So customarily, when you say second cousin 3 times removed, you don't know who is closer to the common ancestor. It's a symmetric binary relation. Whereas for immediate family, if you say niece, niece is not the same thing as aunt, but they're the same type of cousin.
Okay, so this is the second cousin 3 times removed. That's the graph.
Mm-hmm. And if you labeled the one on the right self and labeled the one on the left as second cousin 3 times removed, that would also be accurate. Because it's a symmetric relation. So I'm just.
I see removal is an absolute value.
Mm-hmm.
The removal quantity is an absolute value. So you don't know if I say somebody is twice removed, you don't know if they're much older or much younger than you.
Whereas for immediate family,
I bet that's different in different languages. Anybody know for any other languages?
I don't know for other languages.
So in Spanish, at least, you always use like one of these words, uncle, cousin, nephew, and then you keep saying second, third, but it's a nephew, so it's one generation below you.
Wait a minute. So it's essentially a vector in the tree. It's a second nephew, third nephew. Is that right?
Exactly.
Huh. It's an interesting concept, actually, for our interpretation in terms of Hilbert spaces. But anyway, let's not worry about that. Okay, but here See, I think there's a notation for this, isn't there? That is just some, collection of numbers that just say how far you go back to the common ancestor, how many. I mean, there's essentially 2 coordinate differences. Is that not correct? The distance to the common ancestor and the number of levels different that you are. Am I correct?
Yes, those are the
and
two.
In fact, look at this. I mean, this is
to determine N and K for.
Right. So this is, in fact, what it's giving: difference in generations and generations to common ancestor.
Mm-hmm.
So if I say...
And so it's giving an absolute difference.
Right, I understand.
Yep.
I mean, if I say uncles, parents, and this is where I'm probably parent's son. Okay, this is where it starts mattering that people have 2 parents. Is that right? What the heck is this? Oh boy, these are
representing pairs of parents as a vertex.
Oh, look at this. 6 additional relations with no standard names. Oh boy. Okay, hold on. I should know this stuff. My mother wrote her PhD thesis in anthropology on the theory of a bunch of these relations for different kinds of societies, but it was before I was born, so why should I know?
It's not part of the tree.
What's that?
You're the root of the tree. It's not pictured. It's a bad joke.
Oh, I didn't. Yeah, right. Anyway, okay. Maybe I should look at her. She wrote a book about such issues at some point. Maybe I should look, because it probably has a bunch of information about what. I mean, I assume that these relation names. Yeah, I mean, it'd be interesting to know whether anybody has a fundamentally different way of doing this, because this is clearly what we are doing here is highly, Anglo-centric, so to speak. I mean, maybe not. I don't know. I don't know how universal this stuff is. I know that if you look at, for example, you're allowed to marry your first cousin. I know in England for a long time, the deceased wife's sister was for like ages and ages and ages, was a big sort of is that considered an incestuous relation or not? And so I think that there are these things where you have a certain essentially tree distance that counts as an incestuous relation, and you have a certain, I think the other one in traditional etiquette, right, is how long you should be in mourning if a relation some distance away from you on the genealogical tree dies. So that's another metric on the space of these kinds of trees. There's a piece of complete trivia for you. But in any case, we should at least look up. I mean, there must be information about this, how this works in other societies and so on, where there may be other, and let's see whether we can parameterize it in some more precise, essentially mathematical way, which might just be relations to common ancestor and levels on the tree different. And maybe we don't care. I mean, I don't know whether that has applications in, I don't know, analyzing XML documents or something. The grand uncles of XML tags may or may not be relevant. I don't know. Anybody have a sense of that? I mean, if we're doing genealogy, we're not going to get it right anyway, because as you say, the whole thing is really a DAG. because of the relations being more complicated.
Mm-hmm.
Yeah. And the key important thing is that we cannot handle two parents. So this is like monoparental families on the way.
It's like what?
Monoparental.
Oh, monoparental families. Yeah. Well, I mean, eventually we should be doing something with genealogy where we're actually able to do the actual case of humans, so to speak. Okay.
We discussed this before.
Yep. Okay. XPath. Yes. Expression tree. Okay. We talked about head packing for expression trees.
Right. I don't think we've looked at in detail at the structures, and I have a question there about how custom structures should work.
What kind of custom structures?
So, like, if the user wants to specify a pattern, says replace an expression of this form with a tree of this form, how do they do that?
When would they do this? In expression tree?
Yes.
I see. The basic point is you don't want to explode some piece of your expression tree into this very complicated tree object. You just want to pack those all into a single node. Right? That's the most common case. It's like, I don't want to expand these polynomials out into their individual, variables and powers and things. I just want to pack every polynomial into a single node.
Or for example, associations. We don't want a node for each rule. So each special type of structure, XML, text element, we want to avoid additional connectors there.
I see. In other words,
so provide a large number of built-in structures, but also
right. So you're saying two things. First of all, what's infrastructure and what's data, and the other, how much do you burrow down, and at what point do you just say forget it, it's the leaf? Right. So those seem to be the two issues to me. That you have to pick pick what counts as a leaf. I'm ignoring, complex headdresses and so to speak. Okay. What counts as a leaf? At what point you just say, okay, it's a leaf, I'm going to treat it as atomic. And then what forms of infrastructure you say, I'm going to ignore, this list just represents the collection of children, rather than, well, that's always going to be the case for an expression tree, right? It's oh, I see. It's
well, you may have like some certain kind of expression that you want to handle differently.
No, but let's be specific about that. So a list, the basic point there is you want that to be an anonymous node, right? So in other words, what you want to do is you want to say certain things like list. Okay, two cases in my view. One is what counts as okay, so the two cases, what counts as a leaf, i.e. is atomic. And the second thing is, how do I go from an expression with many subparts into an intermediate node? Okay, so for example, if I have the list, A, B, C, D, whatever, the fact is that I probably want that to be an anonymous node.
I agree.
Whereas, if I have F of A, B, C, D, what do I want to do? Do I want that to be a node where the F is the payload, or what? That makes sense?
Yeah.
Right, that's what we're trying to control. Exactly.
Right.
Okay, do you have an idea for how to do that or not?
Yeah, open the expression tree ref page.
Oh boy. Okay, I think I'm running out of time. I mean, I'm late for another meeting here. He says, looking at this huge thing. Okay. Heads of sub-expressions of the expression. I don't understand this. How is struct just? I don't understand this.
I think we should be looking at the excluded part, which is naming the structures for which we are going to do something special.
What excluded part? I mean, here it's saying structs. What does this mean?
So you could have a list of structures, and if you ran into, you'd test them in order, and whichever ones match, you apply them in order.
Well, what do they do?
They need to specify what the data for the tree is and what its children should be.
So wait a minute. So this is really an association, the struct thing, which says head trees, arrow, some list of patterns. Is that right?
No, head trees is like a named rule that says how to transform an expression into a tree.
Well, what does it mean?
So the head of the expression gets turned into a tree and used as the data, and its children are the trees corresponding to the arguments.
I see. Okay, so that's one style of that. But you're saying something different about when you encounter a particular sub-expression, what do you do with it? Basically what you need to do is you've hit a sub-expression, okay? You hit a sub-expression. And then what do you do? So for that sub-expression, you say extract what the children should be. Okay. Should the sub-expression be atomic? If yes, then you're done. It's a leaf.
Yep.
Okay. Otherwise, extract what the children should be, extract what the payload should be.
Exactly. And so these are the two, like in Nest tree, you would specify this with two functions. And originally there was this idea that you would have left-hand side arrow tree element. But I think that is using tree element slightly differently than how we've been using it.
By the way, Kobev suggests that we define it in terms of space-like and time-like separation, which is basically right. I mean, this is. I mean, it's somewhat these branchial coordinates rather than pure space-like. But well, we could do it. It's like light cones. Okay, never mind.
Binary trees are like that, but we have more.
Yes, we have more than binary trees. Right. Well, that's a case. Wait a minute. Yeah, right. I mean, this is where, the gendered children, it's like sister's cousin's daughter. You've got two colorings of the edges of the in the tree, rather than just a bucket of nodes. Okay, in any case. All right, so you've got various functions for this. I think we're going to have to come back to this one. But let's have a quick look, and then I should disappear. Oh, boy. Oh, there's quite a bit of stuff here, isn't there? Oh, so most of this hasn't been filled in.
Yeah, this is material for examples.
I see. Okay.
To play with.
Okay. Okay, cool. And XML, do you have, oh my gosh, do you have examples here? Yes, you do. You have your tree outline example here, which I think we need a little bit more on the XML thing. I think you also should get some parse trees. I think Chris Cooley has some stuff for his code structure project that is, I think he has parse trees there for code, which are pretty complicated. Does that make sense? The analog. It's the analog of text structure for random C code and so on, right? Do you understand what I'm talking about?
I haven't heard of that, but yeah.
Okay.
Is it Chris Cooley or is it
yes,
Brendan?
Yeah. No, Chris Cooley in Todd's group. And that's almost finished, actually. It's about to go into the function repository. It may already exist there. And it will take arbitrary random languages like C and Java and so on and show you abstract syntax trees and all that kind of thing.
Right. But I can imagine Brenton also has trees.
Yes, Brenton is also probably quite tree oriented. Talking of trees, if you want to find a big pile of trees, all that combinator stuff that I was doing is full of trees. I don't know whether they're relevant to this. Where would we use that? I suppose we could have used that. Yeah. I mean, if you want some, here, I'll just show you a place to get a lot of trees. And the functions that create this stuff are all in function repository now. This is full of trees. Where are they? Well, these are, oh, by the way, these are representations of trees. You can pick these up from the function repository. These are all different renderings of trees, which we probably should have.
The functions to render them are in the function repository?
I hope so.
Okay.
They're supposed to be. I mean, they're recently put there, so.
That's not like the typesetting for a multi-way system or something?
No. Okay, so this is unfortunately not yet really properly set up. I mean, this is right now being loaded in from a cloud file, right? But these are going. I thought they were already in there, in the function repository. But anyway, they're coming if they're not already there. But this is useful. We should have these. These are just different tree visualizations, right?
Okay.
And obviously many trees here. So it'd be good to figure out how we'd represent these trees. Make sense?
Yep.
And notice that, this is the default rendering of the tree, but it's sometimes useful to just say, make it a graph layout. So probably the graph layout option of trees should be supported. That's a complicated thing. If you can do that, I'll be impressed. That's a tree transformation. We should think about how that would work. That's an extremely straightforward thing in terms of standard pattern matching. Makes sense?
This seems like balancing.
Yeah, it's an interesting way to think about it, actually. I mean, it's picking up a bunch of subtrees and doing things. That's the S combinator.
I see.
I never thought about it that way, actually. Anyway, so this is just full of tree stuff. This is another thing that's perhaps of interest. These are DAGs made from trees by finding common subparts, which might be an operation that we would like for some of our trees, right? In other words, find common subexpressions in the tree and DAGify it.
Mm-hmm.
Makes sense? I'm not sure if that's useful, but anyway, yeah, lots and lots of trees in here. You can find one thing might be useful to you here. This is a way of generating really huge trees very easily. I mean, these trees have, this one had whatever it was, 1,000, that's 10 to the 4 elements, but I have ones with much bigger than that. So, okay, I need to go to my next thing. This was very good. This is looking very nice. I mean, this is great. Boy, it's complicated, much more complicated than I thought. But I think it seems like we've now reached we now understand the depth of the complexity. Is that a fair statement? There are not things we expect. As we look at different applications, we're not expecting all kinds of other crazy things to jump out.
No, I don't think so.
Okay. And by the way, in terms of different tree visualizations, menu structures, clearly the visualization for that is rather different, where it's a very horizontally oriented layout of the trees than these other kinds of things.
Mm-hmm.
Yeah, Kobev is mentioning some things about multi-way graphs. first node, path from there, the sub-expression. Yes, I don't think we've thought about this. I need to think about multi-way graphs in a more genealogical way. All right, on to the next thing. Thanks a lot, guys. Thanks to folks on the live stream. And until the next time.